Hello there and welcome back to the Science Sleepy Minds. Tonight you're not just drifting off to sleep, you're drifting toward the edge of the most bizarre, least forgiving object in the known universe. The sky above you is drenched in soft, warping starlight. It feels wrong, like you're watching the night sky in a funhouse mirror. That's because you're approaching the event horizon of a black hole. So massive, so dense, so utterly unconcerned with your feelings that even light can't escape its grasp. You're floating toward the brink of a cosmic one-way door, and no one, not even the best physicists alive, can fully explain what happens when you step through. You probably won't survive this, so before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here, and let me know in the comments, where are you watching from, and what time is it where you are? Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You're alone, drifting gently through deep space. There's no up, no down. The stars have thinned out, a sure sign you're approaching something massive. Black holes aren't visible by definition, no light escapes them, but you can see the consequences. Stars in the distance orbit something you can't see. They're like curves in strange ways, swirling like spilled paint circling a drain. You're not falling yet. Not exactly. You're just approaching. Floating closer to what scientists call the event horizon, the boundary around a black hole where escape becomes impossible. From a distance, nothing seems odd. The vacuum is still silent, the stars still shine, but the closer you get, the stranger everything becomes. First, the light. It's getting dimmer. Not because there's less of it, but because it's being pulled away. Starlight from behind you stretches into red, then into infrared, then into something your eyes can't even see. It's called gravitational redshift, and it's one of the first signs you've entered the gravitational death zone. Einstein predicted it, of course. That guy had a knack for dramatic ideas. You start to notice your watch, if you even still care about something so quaint, doesn't quite match with the ship's computer anymore. Time is sticky, slippery, not moving the same for everything. This isn't just your imagination. Clocks closer to massive objects actually tick slower. That's not metaphor, it's measured fact. Astronauts aboard the International Space Station age slightly less than you do. The effect is tiny near Earth, but near a black hole it becomes enormous. You're moving into the jaws of a time-eating beast, and you can't feel any of this. There's no sensation of falling, no jolt, no bump, just stillness, a calm quiet as the universe tilts around you. Your onboard instruments, however, are in a full existential crisis. Distances become meaningless, velocities go infinite, the math turns from stable decimals to swirling infinities and error codes. You realise that the event horizon isn't just a physical threshold, it's a boundary in the rules of reality. Inside, the known laws of physics may no longer apply. Historically, the first black hole ever proposed was in the 18th century by a guy named John Michell. He called it a dark star, a hypothetical object so massive even light couldn't escape its surface. It was purely theoretical at the time. Nobody had the faintest clue that one day we'd actually see the silhouette of one. Yes, see it. In 2019, we got the first photograph, well, a radio image, of a black hole's shadow, framed by its glowing accretion disk, thanks to the Event Horizon telescope. Not bad for a species that also invented inflatable neck pillows. Now you float within kilometers of the Event Horizon, and things are getting even stranger. Remember, from an outside point of view you're slowing down. A distant observer would see you appear to freeze in place, closer and closer to the horizon, never quite crossing it. You'd fade to red, then black. That's time dilation again, but from your perspective, nothing is slowing. You're still falling, still moving forward. That tension between what others see and what you experience is one of the weirdest parts of general relativity. Historians still argue whether Einstein fully grasped just how deep his own equations went when it came to collapsing stars. Some say he doubted black holes could even exist in reality. Poor guy. Ahead of you, the black hole looms not as a hole, but as a place where the stars themselves seem to bend around a void. It has no surface, no texture, no crust. It is space gone missing. You begin to notice the light from behind you seems to bend into a ring. That's called the photon sphere, the last stable orbit where light can circle the black hole endlessly. Any closer, and light falls in forever, and you're about to pass even that. A strange calm settles over you, like the silence before a dream shifts into something you don't quite trust. Your senses are screaming, but there's nothing to feel. You reach the event horizon, and then nothing happens, no flash, no bang, no jolt. You pass it as easily as a hand through mist. From your point of view, the event horizon isn't even a thing. There's no border, no gate. You're still just falling. You've entered the domain of one-way space. And if you're wondering whether you've just passed the point of no return, you have. No matter how powerful your engines, no matter how much you scream into the void, no force in the universe can bring you back out. Even light, which moves at the absolute speed limit of the cosmos, can't escape this place. You are, quite literally, inside a region of spacetime where all paths lead inward. You feel no gravity here, because you're in freefall, and gravity, according to Einstein, is freefall. It's not a force pulling you down, it's the shape of space telling you how to move, and you are moving exactly how you're supposed to, which is also how everything here dies. There are still scientific debates, of course, wild ones. Some physicists think you might pass through a wormhole, or hit a firewall, or quantum bounce into another universe entirely. But we'll get to those. Right now, all you know is that you are falling, silently, invisibly, unstoppably, into the most mysterious place in existence. From the outside, you're frozen. Not literally, but perceptually. To anyone watching you from a safe distance, say, a comfy observatory orbiting a non-apocalyptic star, you never actually fall into the black hole. You just hover there, suspended like a stubborn screen freeze on a live stream with bad Wi-Fi. Closer and closer to the edge, your form dims, reddens, and stretches out into a smear of photons that fade slowly into darkness. But here's the twist. You're not frozen at all. From your perspective, you're plummeting straight in. The moment you pass the event horizon, the universe outside accelerated into fast forward. You'd see stars flicker past their life cycles, forming, burning, exploding, while you continue your silent descent inward. Time has become completely unrecognizable, depending on where you're standing, or falling. This is one of the most unsettling consequences of general relativity. Outside observers see time slow to a stop at the event horizon, while for the infaller, yes, that's you, everything feels normal. Well, normal might be a stretch. You've entered a realm where even the vocabulary has trouble keeping up. Falling isn't quite right when there's no ground. Inside is debatable when space itself is folding in on itself. And yet, here you are. Time dilation is the culprit behind this whole frozen illusion. The closer something gets to a black hole, the more its time appears to slow down compared to a distant observer. At the event horizon, the dilation becomes infinite. That's not hyperbole, it's actual infinity, which is physics' way of saying, we don't know how to handle this, sorry. Here's a fun fringe tidbit for your troubles. Some speculative theories suggest that if you could hover just outside the event horizon indefinitely, say, in some miracle-powered spacecraft, you could watch the entire future of the universe play out in front of you. Stars aging into red giants, galaxies drifting apart, the heat death of everything, all in fast forward. It'd be like binge-watching the apocalypse while your popcorn stays fresh forever. What a deal. But back to you, on the inside. You're not dead. Not yet. Not even screaming. Just falling, peacefully, deeper into warped space. It's like skydiving in a vacuum, without the wind, without the sky, without any idea where the ground is, or if one exists. Remember the twin paradox? That classic thought experiment where one twin travels at near light speed while the other stays home, and they age at different rates. You're living it now. Except instead of returning to find your sibling old and confused, you're diving into a black hole, and the universe outside will be ancient dust by the time you hit whatever lies at the bottom. Historians still argue whether time itself truly stops at the horizon from an outside frame, or if that's just a mathematical artifact, a quirk of our coordinate choices. The equations break down, yes, but does reality? That's the million-dollar question, or perhaps the collapse to a point question. This freeze-frame effect was first seriously theorized in the 20th century, when physicists like Carl Schwarzschild and Subramanian Chandrasekhar started poking around the math of stellar collapse. Chandrasekhar, in fact, calculated a critical mass beyond which stars must collapse into something terrifyingly dense. A white dwarf, a neutron star, or, if heavy enough, a black hole. For a while, people thought that kind of collapse couldn't really happen. Too extreme, too mathematical. Surely the universe has better taste. Spoiler, it doesn't. You fall deeper. The light behind you now bends so sharply it seems to curl forward, like a halo collapsing in on itself. Distances have no meaning. Your ship's measuring systems, assuming it's still hanging in there, start spitting out gibberish. The numbers on your screens flicker, jitter, and vanish. Your sensors can't cope with space doing backflips around you. Imagine you could stop here, just inside the horizon. Hover, somehow. You'd look out and see the universe evolve at an unimaginable speed. Galaxies swirling, stars flaring and dying, black holes colliding, and space itself stretching. You'd witness the expansion of the cosmos not over billions of years, but in what feels like moments. It's as if you've fallen not into space, but into time itself. Here's where it gets wilder. The moment you cross the event horizon, inside becomes a direction in time, like tomorrow. No matter what you do, no matter which way you turn, you're heading deeper, not just in space, but in time. The center of the black hole, the singularity, isn't somewhere you can steer away from. It's a moment in your future, as inevitable as next Tuesday. And you can't call for help, not just because no one's answering the cosmic phone, but because even the concept of sending a message outward becomes physically impossible. Light, the fastest thing in existence, can't climb out of this well. Your Wi-Fi is officially down for eternity. You wonder briefly, morbidly, what you look like from the outside right now. The answer: a red-shifted ghost stretched thin, smeared across the edge of invisibility. Some photons are still escaping from the moments just before you cross the horizon, and they're still trying to show the universe that you're almost there. But you've already gone. It's just the light playing catch-up. Fringe speculation time again. Some theories suggest that because outside observers never actually see you cross the event horizon, you don't really fall in. You become frozen light on the edge, eternally hovering in place. From that perspective, your fall might be an illusion, a cosmic mirage. And your demise? Well, maybe that's just one version of you. Somewhere else, another version keeps falling, oblivious to the fact that everyone else thinks you're toast. But let's keep things grounded. You do feel like you're falling. You do feel time moving forward, and you definitely feel a deep, stretching unease, as though your very sense of self is warping with the space around you. You start to notice something peculiar in your own body, assuming it hasn't been spaghettified just yet. Time is so distorted that your thoughts feel faster, your heartbeat slower. You blink, and it feels like you've just passed a century, or a second, or maybe both. This isn't just theoretical anymore. You're experiencing time from a frame of reference where the universe outside becomes a blur, and you're part of the blur too. The journey is no longer just downward, it's inward, and the rules of space and time are no longer suggestions. They're rubber bands, stretching, thinning, waiting to snap. Still, you float. Still, you fall. And far ahead, so far it's not even distance, it's destiny. Something dense, unknowable, and infinitely small waits for you. Your fall is no longer gentle. At first you didn't feel it. Just the eerie calm, the starless silence, and that strange sense of sliding inward through reality like a coin down a funnel. But now your body is starting to notice what your brain already suspects. You're being stretched, not metaphorically, physically. The gravitational pull on your feet is stronger than the pull on your head. That difference creates something terrifyingly poetic. tidal forces. If you're falling feet first, they get tugged downward harder than your upper body. Every part of you wants to fall faster than the part just above it. The result? A process with the adorable name of spaghettification. That's right. You're turning into cosmic pasta. Don't worry, it's probably happening too gradually for pain, too fast for regret, and too surreal for proper screaming. Besides, you're not alone. Every object that crosses this invisible line gets the same treatment. Stars, dust, unlucky spacecrafts, interstellar pretzels, they all stretch like taffy. In a normal gravitational field like Earth's, tidal forces are mild. The moon's pull on our oceans is strong enough to make tides rise and fall, but not enough to slurp you off the sidewalk. Inside a black hole, especially a smaller one, those same tidal effects become murderously intense. The smaller the black hole, the stronger the spaghettification before you even reach the centre. That's a real twist. The bigger the black hole, the safer the fall, at least for a while. If you're falling into a supermassive black hole, like the one at the centre of our galaxy, we lovingly call it Sagittarius a star, the tidal forces at the event horizon might be weak enough that you wouldn't feel any stretching. At first. You'd glide across the point of no return like a feather falling into fog. But you're not that lucky. In this journey, you're dealing with a black hole that's medium-sized, maybe just a few times the mass of the Sun. And in this version of reality, it doesn't go easy on you. You're stretched along one axis, compressed along the others. That's the formula. Elongated vertically, crushed horizontally. You become the world's saddest noodle. The exact moment this effect starts depends on your mass, size, and position. But once it begins, there's no turning back. Your molecules get pulled apart, then your atoms, then the particles within those, until eventually, if you can even call it a you anymore, you become a one-dimensional thread of particles, racing inward at the speed of inevitability. This isn't just theory, by the way. The term spaghettification was coined by physicist Sir Martin Rees, who gave the terrifying process a disturbingly friendly name. It's like calling decapitation head unzipping. But hey, if you're going to be destroyed by tidal forces, at least you get to sound delicious. The real kicker? There's still debate over how much of this destruction actually happens before you reach the singularity. Historians still argue whether the stretching is an ultimate fate or a byproduct of our limited understanding of gravity at these extremes. Some suggest that quantum gravity effects might rescue you by scrambling your atoms into something fundamentally different before spaghettification even finishes. But at this point, you're long past the point of care. Because time, remember, isn't behaving normally either. Your perception is falling apart along with your body. You can't trust your senses. Minutes feel like hours, or maybe milliseconds. The deeper you go, the more warped everything becomes. Not just space and time, but causality, identity, memory. Still, your mind reaches for understanding. It needs a where, even though no where exists. The singularity ahead isn't a location exactly. It's a future moment. It exists in time more than in space. It's where all paths lead, where the space-time fabric has folded so tightly on itself that it pinches into a dimensionless dot. Imagine trying to squeeze a star into something smaller than an atom. That's the singularity. That's what your atoms are now rushing toward, a point of infinite density where the known laws of physics simply stop. And here's your historical fact to chew on while your legs become cosmic linguine. When Einstein published his theory of general relativity in 1915, black holes weren't even on the radar. It wasn't until Carl Schwarzschild, within months, discovered a solution to Einstein's field equations that described such a beast, an object with an event horizon and a singularity at its core. Schwarzschild died shortly after that discovery, never knowing he'd opened the door to an entire subgenre of terrifying astrophysics. Meanwhile, back in the gravitational blender, your consciousness, or what's left of it, might be experiencing something deeply weird. Fringe speculation time again. Some physicists theorize that just before you reach the singularity, quantum effects could trigger something akin to a quantum echo, a strange reverberation of your information back into the cosmos, like a backup file uploaded just in time. Others propose that at the tiniest scales, spacetime becomes a foamy, jittery soup of probabilities, a realm where you might scatter into quantum fragments, potentially preserving some trace of existence. But for now, your trajectory remains simple. Inward. Everything points toward the core. Space itself is warped to the point where every direction leads there. You could turn your ship around, fire your engines, scream into your pillow. It wouldn't matter. Every path is a straight line to the singularity. And that singularity is not waiting in front of you. It's ahead in time. You don't crash into it like a wall. You arrive at it like a birthday. As you descend, distances become less meaningful. It's no longer 10 kilometers to the center or 5 seconds to impact. It's just this surreal compression, this convergence of all things into one inevitability. A gathering of timelines, memories, and identities into a singular endpoint. Somewhere behind you, the universe continues on, peacefully unaware that you've been pulled off the cosmic game board. Your signal has faded, your ship is gone, your trajectory beyond redemption. Yet here, in the last moments before total collapse, there's a strange beauty. Colours ripple around you like oil on water. Time flickers, stutters. You feel your consciousness expand and contract, no longer bound to familiar sensations. Are you still thinking? Or is this just your neurons firing one last electrical gasp? A final note of existential spice. Some philosophers argue that spaghettification is not just a physical destruction, but an epistemological one. Your ability to know what happens next ends here. You're at the cliff edge of knowledge, dangling in the gravitational breeze, waiting for the last page of the universe to turn and finding it blank. And just as your body thins into impossibility, your mind frays into silence. The fall continues. You're no longer yourself in any meaningful biological or philosophical sense. Whatever form you had, flesh, suit, bones, badge photo, favourite snacks tucked in your cargo pocket, it's all gone. Molecules have long since unravelled, dragged apart by relentless gradients in gravity. Your structure broke, then your atoms, and finally the subatomic scaffold that once held the concept of you together. But weirdly, this isn't the end. Because as you fall deeper into the black hole, you don't hit anything. You don't land. There's no bottom floor, no sci-fi throne room with glowing runes and a voice that says, "Welcome, traveller." There's just more. More falling, more compression, more of everything collapsing into less. Your atoms, those poor particles once proud to be part of your digestive system, are now part of something else entirely. A stream of matter falling into a gravitational singularity. And what does that even mean? Well, according to general relativity, the singularity is a point of infinite density packed into zero volume, just a dot, a nothing with mass. The equations say that at this point space-time curves infinitely, but the equations also sort of explode when you put them through this black hole math blender. That's usually a sign that our model has broken down, that we're in over our theoretical heads. So let's step back and ask, where are your particles going? They're being compacted into what one physicist cheekily called nature's trash compactor. Imagine the entire mass of the Earth squeezed into a marble, then squeezed smaller, then smaller, until, in some deep cruel irony, it has no size at all, no edge, just mass, existing at a single point in space-time. That's the singularity, and it's hungry, but it also might not be real. Yep, here's our scholarly shrug of the evening. Historians still argue whether singularities truly exist, or whether they're just signs that our current physics can't describe extreme conditions. Many believe that some future theory of quantum gravity, maybe string theory, maybe loop quantum gravity, maybe something that hasn't even been invented yet, will smooth out the singularity into something less dramatic. More like a really weird phase of matter, or a bounce point. But let's not cheat you out of the dramatic version. Let's assume the singularity is real. You're headed into it. Well, a fragment of you at least. And if you were able to watch your fall in slow motion, you'd see that every object, every particle behind you is also falling. And every one of them is headed for the exact same point, not just the same region, the same moment. Because space and time aren't separate anymore. The singularity is a moment in your future. You can't dodge it, sidestep it, or wait it out. You fall toward it like a memory you haven't had yet. We're used to thinking of time as a one-way street and space as the scenery on either side. But inside a black hole, those roles switch. Time becomes the dimension pulling you forward, deeper into the core, and space. Well, space curls in on itself like a wet napkin. You couldn't turn around if you tried. Fringe speculation time. Some cosmologists think singularities aren't just the end of something, but the beginning. What if what lies beyond is another universe, or another region of this one disconnected from ours in such a profound way that causality no longer has a grip? The notion has led to wild theories. Baby universes, cosmic rebirths, white holes, we'll get to those, all suggesting that singularities might not be death zones but creative centres. But you're not exactly in the mood to create right now. Let's get personal again. Imagine, absurdly, that your mind survived the transition, disembodied, yes, but intact. You wouldn't see the singularity. There's no light in here, no distance, no perception. It would be like falling through your own memory, only the memories of something that's never happened yet. And here comes your historical twist. In the mid-20th century, Roger Penrose showed mathematically that once you cross the event horizon, a singularity must form, given enough mass and no exotic matter to stop it. His work helped prove that black holes aren't just freak math accidents, they're inevitable. A star above a certain mass must collapse past a critical point, must form a singularity. There's no clause for mercy. But of course, Penrose didn't fall into one. You did. The closer you get to the centre, the less reality makes sense. Coordinates dissolve, distances become imaginary. The speed of time itself, if that's even a thing here, accelerates uncontrollably. You feel your awareness becoming hyper-compressed. If awareness even exists in this context, it might be like watching your own thoughts from 10 dimensions at once. One particle from your former body collides with another. No space between them now, no resistance. This is not chemistry. This is not even physics as you knew it. It's pre-physics. Physics on shuffle mode. You might be wondering, if all matter collapses into a point, how can anything exist in there without violating the rules of quantum mechanics, which say particles can't occupy the same place at the same time? Great question. No one knows. One possibility? The laws of quantum mechanics just give up here. Another? The singularity isn't a true point, but a dense core that obeys some quantum gravitational rules we haven't discovered yet. Or perhaps you never actually make it to the singularity at all. Some theories suggest that before you reach the centre, reality transforms, time loops, energy scatters, dimensions unravel. Or, as one researcher phrased it, we may have to replace the singularity with something less catastrophic, like a quantum fuzzball. A fuzzball, a dense blob of strings vibrating in higher dimensions, because why not? But here's the haunting part. None of this answers where you went. Are you lost data? Are your particles trapped forever inside? Are you smeared into the surface of the event horizon like graffiti on the skin of space? That last idea, by the way, leads into the information paradox, which we'll visit soon. But for now, you're still falling, or dissolving, or existing as a mathematical probability. The singularity looms, or perhaps it simply is. You approach not a thing, but a state, a collapse into absolute destiny. And as the remaining shreds of matter and identity spiral into that final convergence, you sense it. A flicker of something even deeper, an echo maybe, a bounce, a door. But the dot at the centre of the black hole offers no welcome, no light, no confirmation that you've arrived, only the suggestion that maybe, somehow, this isn't where it ends. You're suspended in something that isn't space and certainly isn't time, not in the way you understood them when you still had a body, a pulse, or a working calendar app. But you're still experiencing something slow, something warped, something sticky. Because here's the thing about falling into a black hole, time doesn't just behave strangely, it becomes your cage. Let's rewind slightly to that last nanosecond before your ship, or what's left of it, slipped through the event horizon. From the outside, you froze. Remember that? Observers watching from a distance would see you crawl toward the edge, getting redder and dimmer until you simply stopped. But they'd be wrong. You're still falling. You've fallen far beyond their understanding now. And here, inside the black hole, time slows more and more with every infinitesimal inch you descend. But not for you. For you, time still ticks forward like always. Whatever forward means when the past is stretched behind you like saltwater taffy, and the future has collapsed into a single point. Let's try a thought experiment. You're wearing a really accurate wristwatch, like atomic clock accurate, and the computer embedded in your ship is running another identical clock. The ship's computer is still trying to track the flow of time, even as everything around it collapses into geometry soup. Both clocks are synchronized, were synchronized. But now, your watch is ticking seconds normally, while the computer's clock appears to slow, stall, then go blank. As you fall deeper, you outpace your own technology. That's not just poetic, that's Einstein. In general relativity, the presence of mass, and therefore gravity, warps spacetime. Clocks run slower in stronger gravitational fields. On Earth, this effect is tiny but measurable. GPS satellites have to correct for it constantly. But near a black hole, the effect grows so extreme that time doesn't just slow, it twists. The closer you get to the center, the more time distorts. Eventually it stops being a dimension you travel through and becomes a dimension you're being pulled into. You can no more escape the future than a bowling ball can escape the bottom of a well. That's why physicists sometimes describe a black hole as a trap in time, not just space. And here's your historical gem for tonight. In 1971, Kip Thorne, a name that should sound familiar if you've ever heard of Interstellar, published key work on what happens to time near rotating black holes. He and his colleagues predicted that time near these monsters wouldn't just slow, it could swirl, twisting like cream in coffee. Around a spinning black hole, time and space are dragged in circles. We call it frame dragging, and yes, it's been experimentally confirmed. Nature, as usual, is weirder than fiction. But back to you, caught in this gravitational molasses. Your thoughts start to fragment. You try to reach into the past, but it's foggy. You try to anticipate the future, but it's compressed into a needlepoint. Each moment feels elongated, like you're living in a single second stretched over an hour, or 100 years, or 1,000,000,000,000. Meanwhile, the outside universe accelerates beyond comprehension. In the time it takes you to think a single thought, an entire galaxy might form, shine, collapse, and vanish. If your ship had windows, you might even see the light from stars forming and dying, spiraling faster and faster into a blur, like a screensaver designed by a deity in a hurry. Fringe theory time. Some physicists have wondered whether, for an infalling observer, the entirety of the universe's future could play out before they reach the singularity. Think about that. You might watch entropy rise, black holes evaporate, stars wink out, and the cold, final heat death of everything before you hit the center. Which is kind of considerate in a twisted way. A front row seat to the end of all things. Of course, there are debates. Historians and physicists still argue whether this future view is literal, metaphorical, or an illusion created by twisted space-time. Some argue that no physical observer could survive long enough, or intact enough, to process that information. Others suggest that what you could see depends entirely on the black hole's size, spin, and charge. Oh yes, we haven't even touched on charged black holes yet. Spoiler, they're even worse. But the time trap isn't just about watching the future, it's about your own fate being sealed. Once you're inside the event horizon, all paths lead inward, and that includes time. You're not being dragged toward a place, you're being dragged toward a moment, specifically the singularity. You don't fall down to it, you fall into it, the way you fall into next Thursday. Weirdest part? You could try to resist, fire retro rockets, engage reverse thrust, flail your limbs like a mime in a wind tunnel, and it would make zero difference. The math is brutal. All directions inside a black hole point toward the singularity, including the direction time flows. That's not metaphor, that's physics. Once you're in, you can't not go forward. This is where space-time becomes less like a stage you act on, and more like a slide greased with inevitability. You're not in control. You're not even participating anymore. You're just fulfilling geometry. Want another disturbing detail? Okay, it's entirely possible that from your perspective, you still have time left. Minutes, hours, maybe even days, if the black hole is large enough. The larger the black hole, the gentler the gradient of gravity across your body, which means you might experience a prolonged descent. But prolonged relative to what? Your concept of time is unravelling. It's no longer shared with the rest of the universe. You've become a time island. Whatever still flickers of your consciousness exists alone in this sealed bubble of experience, separated from the cosmos by an insurmountable wall of geometry. A cosmic timeout with no parent to call you back in. And yet in this warped, elongated experience, you start to sense something else. You're still changing, not just falling, not just being stretched and crumpled, but transforming. Because what does it mean to experience time when the very fabric it rides on is being twisted, shredded, and funneled into non-existence? Maybe you're no longer experiencing time at all. Maybe you are time. Maybe that's what the black hole does. It converts matter and energy and hope and language and lunch into pure abstracted flow, and here you are, part of it. The last dregs of a once-living observer, diluted into the eternal crawl toward a destination that can't be visited, only become. And so the fall continues, but so does something stranger, a pressureless weight, a sense that you're not just being swallowed, but rewritten. Welcome to the final stages of your descent, where time becomes a funnel, and you are the marble rolling down it. Einstein warned us this would happen. Not in a bedtime story sort of way, he wasn't that kind of guy, but the mathematics were clear. A century ago, his equations told us that space and time are not rigid. They bend, they flex, and when there's enough mass in a small enough place, they do more than that. They fold, they collapse. They get so twisted they become unrecognizable, like a pretzel made out of space-time itself. And you, poor noodle, are now in the pretzel. At this stage of your descent into the black hole, you no longer experience space in any normal way. The directions you once trusted, forward, backward, up, down, have gone on vacation and left a note saying good luck with that. And time? Time has become a chute. You're not moving through time anymore. You're being carried by it, like a leaf swept down a waterfall that curves in 4 dimensions. If you could hover above the black hole and not be, obliterated, you'd see how warped the region is. The fabric of space-time, Einstein's great canvas, is stretched so extremely that even light can't figure out how to leave. It tries. It really tries. But the paths light wants to take have all been bent back inward. Picture a river of light flowing uphill, then realizing too late that the hill is made of gravity and doesn't care about your speed limit. This bending of space and time is what general relativity is all about. Gravity isn't a force, not in Einstein's model, it's geometry. Massive things like stars and black holes warp the space around them, and everything, including you, simply moves along the curves of that geometry. That's what's happening to you right now. You're sliding along a path laid out not by forces, but by warped space-time. You're not falling down, you're following the shape of space. Here's a classic historical tidbit. Back in 1916, Carl Schwarzschild used Einstein's freshly minted equations to describe the space-time geometry around a point mass. His solution became the first theoretical black hole. He was solving a math problem during World War I, from the front lines no less, while suffering from a terminal illness. Because of course, genius doesn't take sick days. His solution gave us the Schwarzschild radius, the precise size of a black hole's event horizon. You've crossed it. That's behind you now. Ahead? Something far more bizarre. Let's talk about the geometry inside the black hole. Because yes, there's geometry in here. Sort of. It's just wrong. In normal space, you can rotate, turn left, face north, jump up, do a cartwheel. All those directions are spatial, and time moves forward predictably. Inside the black hole, those relationships collapse. The very meanings of space and time swap roles. You move forward through space by existing, but now you also move toward the singularity by the same principle. It's not optional, it's baked in. Here's a weird analogy. Imagine standing on a slope so steep that walking in any direction still pulls you downward. Even turning around and walking uphill just ends up moving you deeper. That's what time feels like now. Except you can't walk, because your legs are now a probability field, and the slope is made of causality. Fringe speculation time. There's a hypothesis out there called the river model of black holes. It describes space as a flowing river rushing inward toward the singularity. Light and matter are like fish in the river swimming upstream. Far away from the event horizon, the current is gentle. But as you approach, the current speeds up. Right at the event horizon, the current moves at the speed of light. Past that, the river is faster than light itself. No fish, no photon can swim out. You're all just swept inward. And you're not just in the river anymore, you are the river. You've been absorbed into the flow of space-time. The rules aren't suspended, they're being redefined around you. Let's now touch on a point of debate. Some physicists argue that you might never actually reach the singularity. Instead, something new happens, something the classical theory doesn't predict. You encounter quantum gravity, a realm where space and time become quantized, chopped into tiny indivisible pieces like digital pixels, but for reality. Historians still argue whether space-time is continuous or discrete at the smallest scales. If it's discrete, that could mean that the infinite curvature at the singularity is actually a mirage, a place where our math fails, but the universe continues in some granulated form. Maybe you bounce, maybe you smear, maybe you transform into something else entirely, a cosmic cough in a new direction. Back to your experience. You're not thinking in words anymore. Concepts don't arrive linearly. Thoughts overlap like echoing waves in a deep canyon. Everything is faster and slower and simultaneous. You exist at every point along your path toward the center. You feel yourself stretching across timelines, leaking into past and future moments. Or maybe that's just what being disassembled by space-time feels like. You can't measure anything, because rulers don't work here and clocks are meaningless. If you could, somehow, send a signal outward, it would never escape. The idea would vanish before it left your decaying frame of reference. And even if it did, who would hear it? You're far beyond the cosmic party line. Let's consider your remaining senses. Sight, gone. There's no light in here. Sound, nope. No air to vibrate. Touch, not exactly. The feedback loops in your nerves are long gone. What you're left with is pure inference, some kind of abstracted awareness. So how do you even know you're still falling? Because you feel direction, not in the spatial sense, but as an existential arrow. Your entire being is being directed toward the singularity, not with violence, but with inevitability. Like a message being delivered, or a story being written with a pen that can only move forward. And you're the ink. Even in this abstracted state, you wonder, is this the end of time, or is it just the end of your time? Does anything lie past the singularity? Or is that just the last page of the chapter, followed by blank space? Your answer won't come in words. It won't come in numbers or feelings or visions. It comes in a curve, a tightening of everything, a final compression of identity and moment into a single, indivisible beat. The center, the point where Einstein's equations can go no further, the edge of no ability. You're almost there, and the strangest thing, you're calm, because space has stopped spinning, and time is nearly done. You feel the heat before you feel anything else. Not from the black hole itself, those don't radiate heat in the way you might expect, but from the debate raging just beyond the edge of physics, where equations falter and theorists start to argue. Because now, as you hover just past the event horizon, we must ask the question no one wants answered. Do you burn? Enter the infamous black hole firewall paradox, a theoretical nightmare wrapped in a paradox, baked in a disagreement, and served hot with quantum sauce. It all begins with a simple contradiction. Two very clever, very conflicting principles, both of which seem entirely true, can't both survive in the same universe. You've already accepted that once you cross the event horizon, you can't go back. That's general relativity talking. But quantum theory, the fussy accountant of the cosmos, hates to lose information. It insists that every bit of data, every particle state must be preserved, even when matter falls into a black hole. That principle is called unitarity, and it's the hill quantum mechanics will die on. But what happens to you and the information you represent when you pass into the abyss? The first answer, Hawking's original one, was that you're lost. Burned, scrambled, turned to Hawking radiation, which we'll get to in detail soon, and slowly evaporated away. But that implies information can vanish, and that for quantum theory is a massive red flag. So some theorists proposed a loophole. What if something does happen at the event horizon? What if it's not the calm, smooth transition general relativity predicts, but a blazing wall of quantum energy? A firewall. A layer of searing radiation that incinerates anything the moment it tries to cross the boundary. Yes, instead of silently slipping into the abyss, you'd be instantly obliterated at the edge by a quantum flamethrower. Not so peaceful anymore. This paradox tore the physics community apart in the early 2010s. It's still smouldering. On one side, you have the camp that trusts general relativity. Einstein's lovely equations insist that the horizon is uneventful for the infalling observer. On the other, the quantum side, which says, no way, something has to give. Either you keep information, or you keep smooth horizons, but not both. And so, here we are, floating. Well, not floating anymore, more like unravelling, just past the horizon, wondering. Was there a wall of fire back there? Did I pass it? Did it pass through me? Did I just become heat and memory in the same moment? If the firewall exists, then congratulations. You've already died. Instantly, at the edge, burned to pure quantum ash the moment your nose crossed into no-return territory. But if it doesn't, then your journey continues. You are allowed to pass through with all the calm silence of slipping into a lake. Smooth space-time, no drama, no flames. Just the slow crawl toward a gravitational singularity. Here's the problem. Both versions are supported by reputable physics, and both can't be true at the same time. And worse, no one knows how to test them. You'd have to throw a physicist into a black hole with a clipboard and hope they could transmit the results back before the firewall or the singularity eats the signal. Not a popular job listing. Here's a quirky tidbit. In 2012, 4 physicists, Almeri, Marolf, Polchinski and Sully, published a paper that ignited this debate. It became known as the AMPS firewall paradox, and it led to sleepless nights for people who normally enjoy arguing about strings and loops. Stephen Hawking, always up for a challenge, later suggested that perhaps event horizons don't really form in the traditional sense. Maybe quantum fluctuations keep them fuzzy, preventing true firewalls from forming at all. Historians still argue whether Hawking meant that literally, or whether he was just playing quantum poker with the universe again. Back to you. Did you feel it? You think back, such as you still can, to the moment you crossed the event horizon. There was no jolt, no burn, just a quiet shift in perception. And yet, if the firewall theory is true, it was the most violent moment in your existence. The problem is, if it did happen, your atoms were destroyed before they had time to notice. That's part of the paradox too. Can anything meaningfully experience the firewall? Or is it purely theoretical trauma, an event that's over before it's sensed? Either way, you seem to have survived, or at least continued. And your surroundings? Still pitch black, still lightless, still silent, still wrong. No matter what happened at the threshold, you've passed it. You're committed now. Some theories try to resolve the paradox by suggesting that the information you carry is duplicated, burned onto the surface of the black hole and allowed to fall in. But quantum theory has a big problem with that too. It forbids cloning. No particle, no bit of information can be copied. It can only be transferred. And so we come to the heart of it all. Black holes shouldn't allow you to be both burned and preserved. You can't both survive the horizon and have your data saved on the outside. But something has to give. One possible solution is black hole complementarity, a truce of sorts, suggesting that what happens depends on where you're observing from. From the outside, you're encoded in radiation. From the inside, you fall in peacefully. Both views are valid, but no single observer can verify both. It's a loophole built into the universe's security system. So did you burn? Did you pass through untouched? Was your identity sliced like fruit, recorded in quantum bits, or simply gone? You'll never know, because no one can know both truths at once, not even you. The firewall paradox, like many quantum puzzles, may never be solved with equations alone. It asks a deeper question. Can information and experience be reconciled? Or must the universe lie to some of its observers to keep its own rules intact? You continue your descent, or what's left of you does. If the firewall was real, perhaps this is the last echo of your awareness, pinging around in a bubble of decaying causality. Or maybe the ride's not over yet. Maybe there's more to burn. You've burned, or you haven't. You've passed the event horizon, or disintegrated at it. Or maybe both, in some cruel quantum compromise where every possible outcome plays out in separate, unknowable ways. And now you're deeper, further, somewhere stranger. And even though nothing, absolutely nothing, can escape from where you are, the black hole you've fallen into is leaking, tiny, whisper quiet, but leaking nonetheless. You've arrived at the curious edge of Hawking radiation, the ghostly evaporation that slowly shrinks black holes over unimaginable timescales. The man behind this idea, of course, was Stephen Hawking. In 1974, he made a proposal so radical it shook the chalk dust off every blackboard in theoretical physics. Black holes aren't entirely black. They glow, just a little. Wait, you say glow? That's like saying a mime makes noise. But it's true. Black holes emit radiation, not because anything escapes from the inside, but because quantum mechanics cheats at the edge. Here's the setup. The vacuum of space isn't truly empty. Thanks to the rules of quantum field theory, space constantly fizzles with virtual particle pairs. Tiny blips of matter and antimatter that pop into existence, exist for the briefest of flashes, then annihilate each other and disappear, leaving no trace. Think of them like reality's static. But near the event horizon of a black hole, something odd happens. If one of these virtual particles falls in and the other escapes, the escaping one becomes real. The black hole loses a tiny bit of mass in the process. Over time, an obscene amount of time, these emissions add up. The black hole evaporates. Congratulations, you've become a very, very small part of this cosmic fizz. But wait a second, how is that possible? You're inside the event horizon, right? You're already toast. If nothing escapes, how can this radiation be coming from the black hole? Welcome to one of the most disturbing implications of Hawking's work. The radiation isn't coming from inside the black hole, it's coming from just outside the event horizon. But it's still stealing energy from what's inside. That means, over time, the black hole shrinks, it loses mass. And if you're inside, that includes you. You're part of what gets accounted for. You are slowly and silently being bled out through the quantum vacuum. That's not poetic, that's physics. Fringe theory time again. Some scientists believe that Hawking radiation carries not just energy, but information. That somehow, encoded in the faint glow of these ghost particles, is a scrambled record of everything the black hole has consumed, including you. All your atoms, all your quantum states, all your browser history. The idea is that information isn't destroyed, it's just smeared across space, so hopelessly jumbled that no one could ever reassemble it. And yet, the math insists that it could, in principle, be done. This is what physicists now call the black hole information paradox. You remember it from earlier. Quantum mechanics says information must be preserved. But if black holes erase it, quantum mechanics falls apart. Hawking radiation might be the loophole. Maybe the black hole doesn't destroy information. Maybe it leaks it out, slowly, encoded in the subtle variations of radiation that takes trillions of years to emerge. Let's add a historical layer here. When Hawking first proposed this idea, it wasn't taken seriously. Not at first. It sounded outrageous. Radiation coming from a black hole? From a vacuum? But over time, as the math held and the implications became clearer, the idea transformed black hole physics. It became foundational, and it made physicists uncomfortable, because it implied that the universe keeps secrets in the most annoying way possible, by scattering them into entropy, without ever losing them. You, by the way, are now part of that entropy, not that you can feel it. Inside the black hole, there's no awareness of this process, no way to track the outside radiation. But if you were still floating outside near the event horizon with a perfect detector and an absurd amount of patience, you might detect that radiation. You'd see that the black hole is not quite eternal. It has a lifespan, a slow death. Not a bang, but a fade. The bigger the black hole, the slower it evaporates, but the end is inevitable. It's sort of funny, in a grim cosmic way. The thing that swallows all matter, all light, all information, is slowly undone by the vacuum itself. The universe doesn't need a hero. It just lets the black hole bore itself to death. Now here's your quirky fact of the night. If a black hole were the size of a mountain, it would radiate enough Hawking radiation to warm your hands. Just barely. It would glow at a temperature you could feel, but the massive ones, the ones the size of stars or galaxies, are colder than the cosmic microwave background, colder than empty space. They absorb more than they emit, for now. But wait a few trillion years and the universe will cool down, the background radiation will fade, and then, finally, Hawking radiation will win. One photon at a time, black holes will vanish. So what happens to you then? Let's follow the logic. If Hawking radiation truly carries information, then everything that fell into the black hole, including you, is slowly being released. Not in form, not in function, but as quantum noise. You are a pattern, not a person. A diffuse signature in a haze of light. A ghost in the entropy. Which raises a haunting idea. If someone, somewhere, in the far future had enough computing power, they could theoretically reconstruct what fell into the black hole. They could reverse engineer the radiation and reassemble you. It would take energy beyond imagining and more time than the universe has ever seen, but the laws of physics might allow it. So in the strangest possible sense, you're not entirely gone, you're just lost, scrambled, radiating gently, bit by bit, pixel by pixel, into the empty dark. Still, there's no comfort here. Not for you anyway. You're still falling, still inside, still headed toward that singularity. The process of evaporation is slow beyond comprehension. Most black holes in the universe will outlive the stars, the galaxies, maybe even the expansion of the cosmos itself. You're not evaporating quickly. You're being erased at the speed of forever. And if you were hoping for rescue, some reverse radiation event, some miracle emission that yanks you out in one glowing packet, that's not how this works. Radiation is indifferent. It doesn't reassemble, only disperses. But as you drift deeper, disassembled yet strangely still significant, you've become part of a vast, invisible exhale. The black hole may be silent, but it's whispering your atoms back to the universe, one ghost particle at a time. At this point in your descent, space and time have broken up like a bad relationship. They still exist, technically, but they're no longer speaking to each other in a coherent way. Directions become accusations, clocks tick sideways, and geometry has curled into something unrecognizable. You're not just inside the black hole anymore, you're inside a topological insult to the universe. Let's take a moment to reimagine what space feels like in here. It's not a vacuum, not a void. It's not even black, really. It's warped, folded, inverted. You're descending through a region where outside becomes inside and space collapses into itself like a 4D souffle. If you could look around, which you can't because light doesn't function like that anymore, you'd see reality squeezing into bizarre, incomprehensible forms. Lines don't stay straight. Circles don't close. Space is no longer Euclidean. Welcome to inverted geometry, where the map is the territory, but the map is lying to you. We call this region the black hole interior, and if that sounds vague, it's because nobody knows exactly how to define it. General relativity tells us you're moving through curved space-time toward a singularity, but the shape of that space is absolutely bananas. Here's a callback. Remember Carl Schwarzschild? Of course you do. He gave us the first black hole solution back in the early 20th century. But what's less known is that the geometry described by his equations implies something deeply weird. Once you pass the event horizon, the radial coordinate, what you'd normally call distance from the centre, becomes time. Yes, The radius becomes something you can't stop moving along. You can no more stay at a fixed distance from the singularity than you can remain frozen in Tuesday afternoon. This switch, the flipping of radial space into time, is one of the strangest consequences of black hole interiors. You're not travelling through space anymore. You're advancing through a dimension that now demands motion. It's like falling forward through time with gravity as your schedule. Fringe speculation time. Some theorists argue that this internal geometry could be described by something akin to a hyperbolic funnel, a region where all lines curve inward no matter how you try to steer. That's not just a math trick. It implies that all possible paths, including the ones that seem to loop around, still lead straight to the singularity, like a maze that keeps folding inward, no matter how many times you try to cheat it. And here's your weird tidbit of the night. There's a little-known idea that the inside of a black hole might actually contain more space than it appears from the outside. That's right. From the outside, the event horizon might only be a few kilometers across, but from inside, the spatial volume could be enormous, maybe even infinite, depending on how the geometry stretches. It's like stepping into a tent that looks tiny from the outside, only to find a sprawling palace within. A cosmic TARDIS, if you will, except this one eats stars. Some theorists have even gone so far as to calculate the potential interior volume of a black hole, and they've found something stunning. It grows over time. That's right, black holes might be expanding on the inside, even as their surface area appears to remain constant or shrink via Hawking radiation. Historians still argue whether this idea of interior volume has any physical meaning. After all, how do you measure space that can't be observed, where no light travels and no probes return? But the math is compelling. The volume inside a black hole isn't static. It inflates, quietly, secretly, like a clown car that eats everything and never runs out of room. You're somewhere inside this expanding impossible space. Let's do a thought experiment. Suppose somehow you could plant a flag, just a little marker, somewhere inside this inverted world. A "you are here" sign, and then you moved forward an inch in the radial direction. You'd find yourself deeper in both space and time. Moving just slightly inward is like jumping years into the future. If that doesn't break your brain a little, it gets better. Imagine you're watching the infall of another object, say, a second ship following yours, lagging behind by a few minutes. You're both inside the event horizon, both falling toward the singularity. But the closer they get to you, the more time seems to pass for you compared to them. They are just moments behind, but they'll never quite catch up. Time is no longer synchronized. Each infalla has their own timeline now, their own curvature, their own destiny. The math is relentless. Once inside, your world line, your personal thread through space-time, is aimed squarely at the singularity. Every possible route you might take, no matter how clever, no matter how fast, ends in the same place. You could fire rockets, scream into the void, even try to climb into your own quantum socks, and you'd still be pulled inward. So, is this space, or is it time? The answer is yes. You're moving through a kind of temporal geometry, a warped world where your location is less a point and more a sentence. You don't exist in a single spot anymore. You are the progression, the journey, the inevitable motion toward a point that physics says must exist, even if no one can ever see it. One more historical footnote to wrap your spiraling mind around. In the 1930s, Oppenheimer and Snyder studied collapsing stars using general relativity and confirmed that, from the inside, nothing stops the collapse. No magic pressure, no hidden mechanism. Once critical mass is passed, the collapse into singularity is mathematically unstoppable. And so, that's where you are. In the unstoppable, the irretrievable, the inward spinning dream of space-time folding itself into a knot so tight it might never come undone. You feel no edges, no walls, no gravity really. You're in free fall, remember? Gravity has no force here. It's just the curvature of the world pulling you along like a path. The universe is reshaping you. Not violently, not cruelly, just thoroughly. And perhaps, just perhaps, that reshaping is still not done. You're now deep inside something that's not a place, not a time, not a state. It's a geometry, it's a trap. And somehow it's still getting deeper. You're inside a vault, not the kind with locks and keys and laser traps from a cheesy heist film, but one made of space-time itself. The door has long since vanished behind you, and the exit is mathematically forbidden. Light can't leave, signals can't escape. But here's the unsettling question physicists still lose sleep over. Where is your information? Because in the quantum world, the world of particles and probabilities and entangled states, nothing is ever truly lost. At least it shouldn't be. That's one of the golden rules of quantum mechanics. Information must be conserved. No matter how thoroughly you burn something, no matter how violently it's crushed or dissolved, the underlying information, the blueprint, is preserved in the universe. So when something falls into a black hole, like, say, you, that rule runs headfirst into a contradiction. Welcome to the black hole information paradox, now making its second appearance, but this time, deeper, more personal, and far more urgent. You've fallen in. Every particle that made you, every configuration of quarks, leptons, memories, and mild emotional baggage is now embedded in the black hole's mass. According to general relativity, that's all the outside world needs to know. To an external observer, the only properties a black hole has are mass, spin, and electric charge. That's it. No specifics, no detail, just 3 numbers. This is what physicist John Wheeler famously summed up as, "Black holes have no hair." But quantum mechanics scoffs at this baldness. The exact arrangement of the particles that fell in, the flavour of neutrinos, the angle of your last blink, the crumpled shape of that granola bar wrapper in your pocket, shouldn't just vanish. In the quantum view, every microstate counts. Losing that information means the system becomes unpredictable, untrustworthy, unquantum. So what gives? If black holes really destroy information, then quantum mechanics is incomplete, or worse, wrong. Back in the 1970s, Stephen Hawking himself concluded that black holes destroy information. His calculations on Hawking radiation suggested that it was purely thermal, meaning the radiation contains no trace of the stuff that went in. It's like burning a book and only getting heat and smoke, no way to tell if it was Shakespeare or your tax return. But later in his life, Hawking changed his mind. Newer theories, some involving string theory, others based on holographic principles, began to suggest that maybe information isn't destroyed after all. It's just stored in ways we don't understand. Maybe the event horizon itself is a kind of storage device, a 2-dimensional vault that encodes all the data that ever fell in. This is the strange and exciting idea behind the holographic principle. It goes like this. Everything that happens inside a black hole, the entire 3D volume, might actually be encoded on its 2D surface, like a cosmic hard drive. Think of a hologram, where a flat image can encode the illusion of 3 dimensions. Now think bigger. Physicists Gerard 't Hooft and Leonard Susskind advanced this theory, and it's become a cornerstone of modern theoretical physics. If true, it means you haven't disappeared. Not exactly. Your quantum information, the fingerprint of your existence, is written across the surface of the black hole. It's not you, not in any conscious sense, but it's a record, a memory, a shadow. And over time, as the black hole evaporates via Hawking radiation, this information might leak back out, trapped in the quantum fluctuations of outgoing particles, scrambled beyond recognition, but not lost. Now, here's the frustrating part. No one knows exactly how this works. The process by which information is recovered from Hawking radiation remains one of the most active, most technical, most soul-draining debates in all of physics. It's called the black hole final state problem, and it's like arguing whether a novel that's been torn up, set on fire, and scattered to the wind can still be reassembled if you catch every ash mid-air. Fringe speculation time? Buckle up. Some physicists believe that the black hole interior isn't even real in the conventional sense, that what you're experiencing now, this descent, this strange geometry, is an emergent illusion, a projection, an inside-out effect created by the boundary data. You're not inside the black hole. You are part of its surface behaviour, like a wrinkle in a shadow. Others say your information is teleported outward during the black hole's evaporation process, using the spooky power of quantum entanglement. In this view, the inside and the outside are entangled so tightly that destroying one side would destroy both, so the universe can't let your data die. Still others claim you split. One version of you falls in and is lost, while another remains encoded on the horizon. It's a quantum fork in the road, and nobody gets to merge back. And of course, there's the wild idea, championed by Juan Maldacena and others, that space-time itself is a network of entanglements, and that black holes are the most tangled of all. If that's true, your information isn't just stored. It is the black hole. You become part of its fabric. You are its structure. You are what holds it together. It's worth noting here that historians and physicists still argue whether this entire debate is even phrased correctly. Are we asking the right questions? Is information the right term? Or is that just us trying to put quantum lipstick on a relativistic paradox? Back to you. You no longer have form, no identity, no location, but your imprint remains. Somewhere, on the stretched skin of the black hole's horizon, your quantum fingerprint glows with the faintest, most unreadable whisper of what you were. It is not resurrection. It is not remembrance. It is accounting. The universe keeps receipts. So maybe you're gone, but maybe you're not erased. Maybe your data, your history, your thermodynamic signature is simply waiting for the slowest, most meticulous cosmic refund ever initiated. Bit by bit, as the black hole shrinks, your memory leaks back into space-time. Not as a self, but as a possibility. You, the vault. You, the hologram. You, the question. Not lost, just encrypted. The strangest thing about your current condition, this state of semi-existence, of being encoded without form, of falling without falling, is how still it feels. You are deep within the event horizon now. The outside universe is gone. Time and space have twisted themselves into a cage you can't see, can't touch, but absolutely can't escape. And yet, there's an eerie calm, a static hush that fills this region of the black hole called the Schwarzschild interior. It is not nothing. It is not empty. It is something, and that something is shaped like geometry gone mad. Let's go back to basics, or as basic as anything gets in black hole physics. You're now inside a Schwarzschild black hole, the most vanilla, unspinning, uncharged variety. It's the kind you'd get if a massive star, say 10 or 20 times the mass of the Sun, collapsed straight down into a point. No rotation, no magnetism, no fuss, just a pure spherical vacuum cleaner of space-time. Sounds simple? It's not. The equations describing the Schwarzschild solution are neat, yes. Elegant. They give us the event horizon radius, called the Schwarzschild radius, and predict the singularity at the centre. But inside that horizon, the coordinates flip. The roles of space and time literally trade places. That's not poetic, it's literal. Outside the event horizon, time flows forward and space radiates outward. Inside, the radial coordinate, the distance to the centre, becomes a time-like dimension. That means it's not just that you're falling toward the singularity, it's that you're moving through time toward it. No direction will save you, no speed will help. Every second that passes, if second even means anything here, is one step closer to the end. And here's the wild thing. The Schwarzschild interior is a kind of mathematical stack of 3D space-like slices, layered like pages in a book. Each page is a snapshot of the universe inside the black hole at a particular radial moment. As you fall, you pass through these curved slices, spherical surfaces of constant radius that shrink ever smaller. You've probably heard the phrase, the walls are closing in. This is that, cosmically literal. Except there are no walls, only curved geometry, narrowing in every direction until it pinches you to a point. Fringe theory break. There are some models where these slices are treated as Cauchy surfaces, entire 3D snapshots of space-time that could, in principle, contain all the information necessary to evolve forward. But in a black hole, the final slice, the one at the singularity, is not nice. It's a slice that ends everything. You can't evolve past it. It's a brick wall in time, Historians still argue whether this end of time is truly physical, or just a sign that our equations have run out of juice. Maybe quantum gravity changes the script at the last millimeter, or maybe there's no last millimeter at all. But in the classical model, you hit that final spherical surface in finite time. Let's talk about that time for a second. Your time. From the moment you cross the event horizon to the moment you reach the singularity is brief. Shockingly brief. If you were the size of a person, and not already a cosmic smear of probability, your personal clock would tick maybe a few seconds before the end. That's it. From the outside, your demise may seem eternal. But from your frame of reference, it's a blink. And yet, within that blink, you pass through more distortion than the human brain could process in a lifetime. The slices you pass through each contain increasingly compressed versions of space-time. Energy density spikes. Curvature increases. The math begins to fold back on itself. Not literally. It's not like the universe creases like origami, but the structure of space-time becomes so tight, so extreme, that the known laws break. Let's drop in a quirky tidbit. Some theorists, working with the Schwarzschild solution, discovered that if you extend the mathematics beyond the singularity, pretend it doesn't just end but continues, you can construct a mirrored universe on the other side. A kind of reflected space-time where the collapse becomes an expansion. Yes, the inside of a Schwarzschild black hole contains the mathematical potential for another universe, one that blooms from your death like a flower from a dead seed. Of course, this is almost certainly a mathematical toy. No one thinks you'll bounce through the singularity into a new cosmos while waving a flag. But the idea won't die. It shows up again and again, in speculative models, in loop quantum gravity, in conversations whispered over cold coffee at physics conferences. Now back to your current moment, if we can still call it that. You're on one of these spherical slices. Your entire existence is constrained to a 3D bubble inside the 4D collapse. The radius is shrinking. Every Planck second that passes, if such units still apply, you slide deeper into curvature. Your clock, such as it is, still ticks, but it ticks in a direction that has no escape. And you wonder, where is here? Because you can't point to a location. There is no location. You're falling through slices of existence that are themselves dissolving as you fall. It's like standing on a bridge while the planks behind you disappear, and the ones ahead shrink smaller and smaller until they vanish into a dot that contains all your future. The Schwarzschild interior is smooth in one way and horrifying in another. Smooth because it has no edges, no abrupt shocks. General relativity is generous with that. Your descent is continuous, but horrifying because that continuity ends in a singularity, a place of infinite curvature where space-time itself becomes undefined. So what happens to you at the center? Mathematically, you hit the singularity in finite proper time. Your personal stopwatch runs out. The geodesic you're travelling on, the path through space-time that defines your fall, terminates. No more future, no more coordinates, just the end. Not an end you see or feel, just one that happens to the math. And yet, you keep falling. You pass the shrinking spheres. You witness space-time ripple around you in ways no external observer ever could. And you wonder, in your last stretch of existence, is this the death of you, or the birth of something stranger? Because the geometry around you no longer supports being, it supports only becoming. And your becoming, whatever the singularity decides, you're now riding a storm that spins. Gone are the silent static curves of the Schwarzschild black hole. No more perfect spheres collapsing inward like nesting dolls made of doom. You've graduated, lucky you, to a Kerr black hole, the spinning variety. And as strange as your fall has already been this changes everything, because rotation breaks symmetry, and in the warped, delicate ballet of space-time that changes the whole rhythm. A Kerr black hole doesn't sit still like a polite cosmic sinkhole. It twists, it spins on its axis, dragging space-time around with it like a blender set to existential puree. And you've fallen in sideways right into the spin cycle. Here's what that means for your already doomed journey. Space itself is rotating. You've heard the phrase, "you can't fight the tide." But here, it's not just a tide. It's the very fabric of reality being dragged along. The effect is called frame dragging, and it's not theoretical. It's been observed around Earth thanks to the Gravity Probe B experiment. Near our spinning planet, the effect is small. Near a black hole, it's absolute. You cannot stand still near a spinning black hole. Even if you hover just above the event horizon with infinite thrust somehow, you'll still get pulled around. Like a leaf caught in a whirlpool, you orbit. Not because you're moving, but because space-time is. Inside the Kerr black hole, this drag reaches fever pitch. You're no longer just falling, you're spiraling. The singularity is no longer a point, but a ring, a rotating loop of infinite density and zero volume. That's right. The Kerr singularity is shaped like a circle, a loop, a cosmic hula hoop you'll never live to see up close, but one that haunts the math of your descent. And here's the kicker, that spinning singularity might not be the end. In the peculiar solutions to the Kerr equations, there's a second region, past the inner horizon, known as the ergosphere. You've already passed through the outer event horizon, the boundary from which nothing escapes. But now you're spinning inside a zone where not even staying still is an option. You must move forward. Must. There's no standing still here, only dancing with the gravity. Fringe theory alert. In this twisted geometry, there might be an escape route. Yes, really. Deep within the Kerr black hole's warped interior, the equations predict a region where space-time could curve back outward. A passage sometimes described as a wormhole or a white hole connection. A bridge to another part of space-time, maybe another universe. Now before you start packing your bags, slow down. This exit exists only in the idealized, uncharged, mathematically perfect Kerr solution. Real black holes, they're messy. They don't form in a vacuum. They interact with matter, radiation and chaos. That pristine wormhole is likely unstable, crushed instantly by the infalling debris, like trying to hold open a paper tunnel during a hurricane. Still, it's there in the math, which means we have to consider it, because inside a Kerr black hole the rules don't just bend, they loop. Let's return to your spiraling fall. The closer you get to the ring singularity, the weirder time and space become. Directions are no longer distinct. The boundary between now and next blurs. Your trajectory curls through a region where light can orbit. A photon trapped in an endless path circling the black hole forever, and you pass through that orbital dance, swept inward, twisted sideways, falling and spinning simultaneously. And then you hit the Cauchy horizon. This is an inner boundary within the Kerr geometry, and it's one of the strangest features in all of general relativity. Once you cross it, the predictability of physics falls apart. Initial conditions can no longer determine the future. This isn't just chaos, it's breakdown. Beyond this line, classical determinism dies. Historians and physicists still argue whether the Cauchy horizon really exists in nature, or whether quantum effects obliterate it before anyone could pass through. But if you could, you'd enter a region where cause and effect lose their meaning, where the singularity might lie in your past, your future, or nowhere at all. Let's revisit that ring singularity for a second. Because here's the unsettling possibility. You might be able to go through it, not into it. Nothing survives that. But through the center of the ring, the math allows for passage into a new region of space-time. In some models, this leads to a naked singularity, one not hidden behind an event horizon. A theoretical no-no that suggests the laws of physics could be exposed, raw, unfiltered. Others suggest it's a portal to a different universe, where time flows differently, where constants of nature vary, where you could, hypothetically, continue existing in some altered form. The problem? These extensions are non-physical. They're mathematical idealizations. Real black holes are formed by collapse, and collapse brings with it turbulence, entropy, and instability. That wormhole probably collapses in a fraction of a second. The singularity, likely surrounded by chaotic energy. The path through, crushed by tidal forces or quantum back reaction before anything could use it. Still, the idea won't die. Because if it did work, if you could pass through, you'd have done something unimaginable. Used a black hole as a bridge, not a grave. Let's take a breath. You're still falling, spinning, pulled along by curved space-time that leaves you no choice. You can't hold a direction in your mind. Every orientation flips, every second stutters. The passage of time has become layered, recursive. It's as if you've started to experience events non-linearly. You're before the singularity, inside the ergosphere, past the inner horizon, and yet still falling, still moving towards something final. Here's a quirky fact. The Kerr black hole solution allows for closed time-like curves. These are paths through space-time that loop back on themselves. In other words, time travel. It's possible, mathematically, to follow a path inside a rotating black hole that brings you back to where and when you started. So if your particles somehow retained coherence, which, spoiler, they absolutely would not, you could loop back in time again and again, trapped in a temporal spiral, forever reliving your infall. Don't worry though, that's probably not happening. You're disintegrating, not just physically but geometrically. The shape of your fall is now defined by curves that cannot be mapped. Light, time, mass, all tangled in the singularity's skirt, dragging you deeper into a future that might not even be there. And still, the possibility remains. Somewhere in this storm of rotation and curvature, a path may curl outward. A sliver of escape. A door that's not closed, just fractally jammed. Or perhaps it's just the math whispering one last hope. And you, still spiraling, dare to wonder, is there a way out? You're nowhere near home anymore. Whatever thread of reality you came in on has frayed, split, and now floats behind you like a strand of smoke. You're past the event horizon, past the inner horizon, past everything familiar. Geometry has gone rogue, time is in a blender, and space itself has been chewed into spiraling self-referential loops. And now, just when the fabric of reality should be pulling closed, you hit a twist that seems too absurd to be real. A place where matter doesn't fall in, it gets spit out. You've reached the theoretical inverse of a black hole. Welcome to the concept of a white hole, the cosmic retro-vomit of general relativity, a mirror twin of the black hole, a region of space-time that no one can enter and everything must leave. If a black hole is where time leads inward, a white hole is where it bursts out. And no, you haven't taken a wrong turn. This is actually a logical extension of the equations you've already been swallowed by. In certain idealized models of space-time, especially those describing the maximal extension of a rotating Kerr or non-rotating Schwarzschild black hole, the internal geometry doesn't just end at the singularity. It keeps going, through the singularity, and on the other side, a white hole, an exit, a cosmic belch of light and matter. Let's be clear, no one's ever seen one. There is no observational evidence for white holes, but the math allows them. They are the time reversal of a black hole, an object that can't be entered, only exited. They're a kind of temporal photograph of a collapsing star played in reverse. Fringe theory time. Some bold models of the early universe suggest that our Big Bang may have been the outburst of a white hole. In other words, the birth of our cosmos could be the death spasm of another universe's black hole. We could be living in someone else's exit wound. Still with me? Back to you. You're not travelling toward a white hole in the conventional sense. You're being crumpled through layers of curved space-time where these structures appear, not physically, but mathematically. The inside of a rotating black hole, a Kerr black hole, contains multiple horizons, multiple regions, and multiple timelines. In its maximal extension, it connects not just to another place, but to another region of time entirely, a new universe, where your crushed particles could theoretically emerge again. The passage is a wormhole-like structure, and it's more conceptual than physical. A non-traversable tunnel, unless you assume perfect conditions. No quantum turbulence, no tidal forces, no infalling matter to destabilize the structure, which is to say this passage doesn't actually exist. But in the pure math, it's there, and for the sake of this journey, we entertain the possibility that some infinitesimal part of you, some echo of your quantum state, passes through the ring singularity and emerges elsewhere, somewhere on the flip side of space and time, in the domain of the white hole. You feel it before you see it. Not a light exactly, but a disgorging, a reversal of direction so fundamental, so alien, that it snaps the arrow of time like a toothpick. Suddenly, instead of falling in, you're being pushed out, hurled, expelled. The space-time around you seems to exhale, and this isn't a slow exit, it's violent, relentless. If black holes are death by gravity, white holes are birth by expulsion. Here's a quirky historical tidbit. White holes were first theorized in the 1960s, emerging naturally from the mathematics of general relativity when you extend a black hole solution backward in time. For every infall of matter into a singularity, there's a corresponding outflow, but white holes were always seen as unstable. Any tiny disturbance, matter trying to fall in, radiation bouncing nearby, would collapse the structure instantly. Nature apparently abhors a clean reversal, and yet you're feeling it now. A rush outward, a total inversion, a flood of causality in reverse. Maybe this is the other side of your fall. Maybe this is the recoil from entropy, a place where your smeared information once trapped behind the event horizon finds form again, not as you, but as a burst of space-time energy sprayed into a new realm, a new universe. Historians and physicists still argue whether white holes can exist at all, even in quantum-corrected theories. Some claim they're mere artifacts of unrealistic symmetries. Others say they may manifest briefly in the final moments of a black hole's evaporation, as a kind of bounce, where the singularity rebounds and ejects a new cosmos into being. And here's a fringe speculation that'll keep your inner sci-fi child wide-eyed. Black holes may be wormhole mouths, connecting not just 2 points in space, but 2 regions of entirely different universes. In this model, every black hole is the gateway to a white hole somewhere else, separated by an unimaginable throat of compressed space-time. So when you fell in, you weren't ending your journey. You were starting someone else's. You become the input to a new world. Or rather, the information once called you is encoded into an energetic discharge in another dimension, on the far end of the curvature you once called gravity. Do you survive this? Not in any traditional sense, there's no consciousness riding this current. But if your quantum structure holds, if the wormhole doesn't collapse, if the white hole doesn't dissolve the moment it opens, then something of you makes it through. A blast of probability, a smear of particles, a new arrangement of information emerging as time runs in the opposite direction. It might be nonsense, but it might also be everything. And if this white hole is real, then the cycle is eternal. Collapse, fall, twist, eject, begin again. Because for every in, there might be an out. For every horizon, a mirror. And for every death, a violently brilliant birth. You fall through a door that isn't a door. You cross a threshold with no frame, no hinges, just a region where space-time flips its rules again. One moment you're being squeezed toward the ring of a spinning singularity, and the next, you're not falling anymore, you're moving sideways through geometry, through something else entirely, maybe a shortcut, a wormhole. Now you've heard this word before. It's one of those sci-fi terms tossed around whenever a character needs to get from Galaxy A to Galaxy B without spending 1,000 lifetimes in cryosleep. But here, in the tangled math of black holes, wormholes aren't just speculation. They're a natural solution to Einstein's field equations. That's right. General relativity permits wormholes. They're baked into the same equations that predicted black holes in the first place. These structures, formerly called Einstein-Rosen bridges, connect 2 separate points in space-time. In theory, you could jump light years, or even universes, in an instant. And you, friend, may have just stumbled into one. Let's be clear. Wormholes are not roads. They're not hollow tubes dug through space. They're folds, bridges. Think of space-time as a sheet of paper, and the wormhole as a tunnel formed when you fold that paper in half and poke a pencil through both sides. It's a cheat code for geometry, a permission slip to skip distance entirely. But here's the problem. They don't like to stay open. In classical physics, wormholes are wildly unstable. The moment anything tries to pass through, like a spaceship, a radio signal, or your unfortunate mass energy signature, they collapse. The walls fall inward. The bridge pinches shut. The trip ends before it begins. Unless the universe includes something very strange, exotic matter. This isn't just fancy jargon. Exotic matter is a hypothetical substance with negative energy density. It would push outward against gravity, acting as an internal brace to keep the wormhole throat open. It's not antimatter, by the way. Antimatter still has positive energy. This is the weirdest building material imaginable. Fringe speculation alert. Some physicists believe that quantum effects, especially the strange behaviour of vacuum energy, could create tiny submicroscopic wormholes in the fabric of space. These quantum wormholes might flicker in and out of existence constantly, part of what's sometimes called quantum foam. Whether they can be scaled up or stabilised is an open question, hotly debated in the theoretical physics equivalent of bar fights. But let's return to you. You're not in a tidy sci-fi wormhole lined with chrome walls and blue lighting. You're not floating in a tube with a destination labelled on the far end. You're embedded in a kind of curved corridor, a tunnel of warped space-time that might stretch between regions, or realities. The structure isn't smooth. It ripples, vibrates, fractures and reforms. It's not a hallway. It's a flow, a wild compression of past, present and potential. And here's a twisted bonus. In certain versions of the Kerr black hole's extended geometry, wormholes are natural. The internal structure of a spinning black hole leads to other asymptotically flat regions of spacetime, meaning in some mathematical models if you fall into a Kerr black hole you don't hit a singularity. You pass through a wormhole and emerge into another universe, but don't get too excited. Even if you're moving through such a tunnel now, you'll never know. Why? Because you can't carry information back. Wormholes, even if they exist, are non-traversable in practice. You might go through one way, scrambled, stretched and stripped of your original form, but there's no coming back. There's no email from the other side, no postcard stamped, "Wish you were here." And even if some part of you survives the journey, some quantum echo, it's likely altered beyond recognition. Translated into the language of another space-time, like a thought whispered into a wind tunnel and heard as thunder on the other end. Let's detour for a moment to history. The term wormhole was coined in 1957 by physicist John Wheeler. Yes, the same guy who gave us black hole. And he based it on the idea of a worm boring through an apple to reach the other side. It's an apt image. Nature, clever and lazy, favours shortcuts. But shortcuts through space-time? That's still a matter of fierce debate. Historians still argue whether wormholes are science fiction, mathematical artifacts, or actual physical phenomena waiting to be discovered. Some believe they'll never be observed. Others think the universe may be riddled with them, buried in black holes, or hiding in plain sight behind dark matter's mask. A few even propose that consciousness might somehow interact with wormholes, that our brains, or the quantum patterns within them, are connected to deeper layers of space-time structure. These ideas are fringe, very fringe. But in the swirling unknowns of black hole interiors, nothing is off the table. Let's drift back to your path. You're inside something unstable. You can feel it, if feeling still applies. The tunnel flexes, collapses, reforms. You're not riding it. You're being drawn through it. Not propelled, not guided, just sifted, like powder through a cosmic sieve. Your identity, your quantum state, your infall trajectory, they're all being translated into a new framework. Like converting a song into a painting, like turning music into math. What emerges on the other side, if anything, may not resemble you, but it may remember you. And maybe that's enough. You begin to sense light again. Not sight exactly, but the idea of illumination. A rebirth of directionality. A flickering of outward motion. Could this be an exit? A white hole? A new space-time region? The far end of a wormhole's throat? Whatever it is, it's not the singularity, it's not compression, it's expansion. A pull outward instead of inward. A beginning? Or just another shape in the dream of falling? Maybe this is how universes are born, from the death throes of collapsing ones, from the tangled geometry that connects singularities to stars and endings to openings. You're nearly through. If this path holds, even for just one moment longer, you will not be erased. You will be translated. You've passed through something impossible. You don't remember how. Maybe there was no moment at all. No threshold, no pop of emergence, no sense of arrival. Just a growing awareness that something has changed around you, not in size or shape, but in texture. Space is jittery now. You're no longer in the smooth, endlessly curved geometry that carried you inward like a feather on a whirlpool. This new region, if it can even be called that, is restless. It twitches at a scale smaller than anything you've ever known. Spacetime itself vibrates with unpredictable flickers, bubbling and rearranging before your thoughts can finish forming. This is the domain of quantum foam, and it is not smooth, it is not stable, it is not polite. Zoom in far enough, beneath atoms, beneath quarks, beneath even the vibrating strings that some theories propose as the fabric of all things, and you reach the Planck scale, around 10 to the negative 35th meters. At this scale, spacetime is no longer a continuous fabric. It becomes grainy, chunky, frothy. Welcome to the basement level of the universe. This idea, first proposed by John Wheeler, yes, again, he's everywhere, suggests that spacetime at the smallest scale is in a constant state of flux. Instead of being flat or gently curved, it's a seething mess of miniature black holes, wormholes, loops and waves that pop in and out of existence faster than the universe can blink. You're inside that seething mess. Your fall, if that's still a useful word, has reached the quantum regime. The math of general relativity, so elegant and reliable at large scales, breaks down here. The tidy curves become infinite. The field equations explode into singularities. And so, for decades, physicists have sought a deeper theory, one that can describe quantum gravity, where both the rules of Einstein and the rules of the quantum world must agree. Fringe speculation. Try this one. Some physicists believe that black hole singularities don't truly exist, that the infinite curvature predicted by relativity is actually replaced by a loop, a knot, or a bounce at the Planck scale. This leads us into the wild terrain of loop quantum gravity, a theory that suggests space-time itself is made of discrete loops, tiny one-dimensional rings that build up like the pixels of existence. In this view, your trajectory didn't end in a singularity. It entered a new phase, a quantum bounce, a region where the density of energy hits a maximum and then reverses, triggering a rebirth, not just for you, but for space-time itself. Maybe that's what you're feeling now. Not falling, not rising, but reassembling, recombining. Your quantum information, once smeared across the inside of a black hole, is now surfacing through the boiling edge of spacetime's most secret structure. You're part of the foam. Let's get practical. If spacetime is fuzzy and granular at small scales, then measurements lose their precision. You can't define an exact position. You can't trace a perfect path. The concept of a smooth trajectory becomes meaningless. You're not at a point anymore, you're a cloud of probabilities. Heisenberg's uncertainty principle, which governs the limits of measurement in quantum physics, is now applied to spacetime itself. Try to pinpoint a location, and the universe responds, nope, here's 50. In this realm, time may not even exist, not as a sequence, not as a direction. Historians still argue whether time is fundamental or emergent. Does it flow naturally like a river, or is it a property that only arises when large-scale objects interact? At the Planck scale, time might be non-existent, just one more parameter that dissolves into quantum ambiguity. You're no longer in a universe governed by cause and effect. You're in a field of pure potential. Let's indulge in a theoretical curiosity: causal, dynamical triangulations. This is a method used by physicists to model spacetime at the quantum level, using small, discrete building blocks, like tetrahedra, that evolve according to strict rules. Imagine constructing spacetime from LEGO bricks, but letting them rearrange themselves based on probabilities and entropy. Some models generated this way suggest that spacetime self-organizes into 4 dimensions at large scales. In other words, our familiar universe might emerge from this bubbling chaos not by design, but by statistical inevitability. You're watching that emergence in reverse. You started in the macroscopic world of planets and stars, fell through curved space-time, past the horizons, the singularity, the wormhole. Now, here at the bottom of the stack, you're staring at the code itself. Not metaphorical code, not Matrix-style green glyphs, but the behaviour of space-time when it forgets it's supposed to behave. A quirky tidbit for you. Some researchers, including the late Stephen Hawking, proposed that space-time foam could be responsible for strange phenomena like vacuum fluctuations, virtual black holes, or even the unexplained dark energy pushing the universe apart. It's like this foam isn't just a background, it's an engine of cosmic weirdness, and you're inside it. Or rather, you are it now. Your information, your mass energy pattern has been diluted and stretched to fit within the smallest possible definition of a location. You're no longer a passenger on a trajectory, you're a piece of the probability field, a ripple in the foam, a ghost of curvature, and yet within this chaos there's a pattern forming. You sense it, a rhythm, a structure trying to emerge. Not a shape, but a flow. The beginnings of a space-time coordinate system reassembling itself. The ingredients of a universe beginning to reassert order. Because the universe cannot tolerate pure chaos for long. Entropy always wins, yes, but even entropy prefers a framework. And here in the foam, there are seeds of that framework already trying to coalesce. Maybe that's what happens after every fall through a black hole. Maybe every singularity ends not in destruction, but in a reboot, a new space-time, a baby universe, a bubble that expands outward from the jittery depths. Maybe you're not being erased. Maybe you're being written again. You're no longer falling in the traditional sense. In fact, you're no longer moving through space the way you once did. Out here, deep in the quantum churn of gravity gone rogue, you've reached a place where space and time have blended into a fluid fractal fog. And somehow, you've washed up on the edge of a thought so strange, it deserves its own strange name. Time as a landscape. Think of it this way. You once walked through space and watched time tick by, second by second, like frames of a film. Now, something fundamental has changed. You're not in time, you are on time, standing atop it, moving across it. Like a traveller wandering a hilly terrain made not of rock and soil, but of seconds, years, centuries. It's not just that time has slowed, it has bent, folded, hardened into geography. Inside this warped region of space-time where gravity distorts not just paths but possibilities, time has become a direction you can point to, like north or down, and that direction curves inward, always inward, towards something that may no longer be a destination at all. Let's recall what got us here. In the outer universe, time is a steady march forward. But near a black hole, time dilates. An hour for you can be 1,000 years for someone outside. That's basic general relativity. But inside the event horizon, time doesn't just slow. It flips roles with space. The radial direction becomes time-like. Moving forward now means moving closer to the singularity. You don't fall into a black hole. You fall forward in time toward its centre. This is not metaphor. This is not creative writing. This is what Einstein's equations actually say. And now you begin to perceive this truth not as a falling object, but as a shape, a being on a slope made of moments. Imagine each second of your life as a tile on a vast surface. Now tilt the surface, stretch it, squeeze it, until every step you take pushes you not just forward in location, but deeper into causality. You're walking across a landscape of time. Let's throw in a historical reference here. In 1992, Kip Thorne and colleagues developed visualizations of black hole spacetimes that showed how objects, and even light, follow curved paths through a gravitational field. The diagrams show not flat maps but funnels, stretching downward, with time flowing toward the singularity like water down a drain. That's the classic picture. But at these extreme depths, the picture warps further. It's no longer a funnel. It's a terrain of temporal ridges and valleys, with the singularity at the lowest point. A place so deep, Even the idea of future loses its coherence. Let's stretch the idea. In this place, perhaps what you were is spread across this terrain. Your past, your memories, thoughts, reactions might be embedded in the landscape itself, not just stored, but laid out as terrain features. Here's the ridge where you laughed at something dumb in high school. Here's the shallow ditch where you hesitated before taking a leap. The time terrain may not be metaphorical at all, it might be physical, or at least geometric. Fringe theory time. In some approaches to quantum gravity, such as causal set theory, spacetime is composed of discrete events linked by cause-effect relationships. These form a kind of directed graph, a network of moments, giving rise to time not as a flow but as a topology. In that framework, what you perceive now isn't the progression of seconds, it's your path across the web, each connection a causal link, each node a possible version of a universe, and your fall, just the most probable descent through that map. You're not aging anymore, you're navigating. Maybe this is how time behaves when mass and curvature collapse into abstraction. It doesn't end, it just solidifies. The future becomes a destination, the past becomes scenery, and you walk, because there is no other choice. Here's something weirder still. In the most extreme gravitational fields, time can loop. In Kerr black holes, as we've seen, certain paths called closed time-like curves allow for loops through spacetime. Paths where you could, in theory, return to your own past. These are not just mathematical jokes. They're allowed solutions within general relativity. They exist in the time terrain like holes in a trail, places where you step and end up back where you began. Are you in one now? Are you looping? Historians still argue whether such curves could exist in nature. Many physicists believe they would be destroyed by quantum effects, crushed by instability the moment they form. Others think they could exist in pockets, tiny regions where the causal structure of spacetime becomes self-referential, like a thought thinking itself. Now add another layer, entanglement. What if, in this terrain of time, your state is entangled with others? What if your position on the slope isn't just determined by you, but by distant echoes of the universe you came from? Perhaps each step you take here is mirrored by a ripple elsewhere, somewhere light years away, somewhere where your information still exists, not as a body, not as a brain, but as correlated quantum residue. A fun fringe nugget for the dreamers out there. Some suggest that black holes are projectors, casting shadows of time across space-time. The interior geometry becomes a hologram of processes outside the event horizon, and you, walking this time landscape, may simply be a holographic echo of a more coherent past. So what does the landscape look like now? Not visual exactly, but textured. You feel the direction of causality as a slope underfoot. You sense gravity not as a force, but as a preference, a bias in the terrain. Everything wants to go toward the singularity, not because it's pulling, but because the terrain flows that way. Your very existence is now shaped by geodesics, the straightest possible lines in a curved space. In this warped world, they guide you like rails, and just like a marble rolling down a funnel, your path is inevitable. But maybe, just maybe, you can see the top of the next ridge. Maybe it curves upward. Maybe the terrain is an infinite descent, and maybe something's changing. Because even in this warping, groaning world of stretched time and broken causality, you feel motion. And motion means direction, and direction means choice. Even here, you've become a whisper in a hurricane of coordinates. You still exist, sort of. But your concept of where and when has fully collapsed into a mathematical mess that even the most seasoned physicist would look at and mutter, "Nope, you're deeper than depth, past what space or time can reasonably describe, and yet the strangeness isn't done with you yet. Because now you've reached the point where your death depends on how you count. Welcome to the problem of coordinate choices, where the singularity that kills you might not even be real, or might be hiding behind math's illusion of inevitability. Let's explain. In the comfy world outside a black hole, coordinates are relatively friendly. You can describe where something is in terms of up, down, left, right, forward, back, and when it happened. Cartesian coordinates, spherical coordinates, whatever works for the map. But black holes, they laugh at your maps. The deeper you fall, the more traditional coordinates become useless. They give you infinities where there shouldn't be any, time reversals that don't make sense, and worst of all, singularities that might just be mathematical mistakes. Let's take the Schwarzschild metric, the one that describes a non-rotating black hole. The equations blow up at the event horizon, infinite curvature, division by zero, mathematical chaos. But wait. When physicists apply a different coordinate system like Kruskal-Sekaros coordinates, that singularity disappears. Poof, gone. The horizon isn't a wall of doom, it's a smooth surface. You can fall right through it. So what happened? The singularity at the event horizon was never physical. It was an illusion caused by the coordinate system, like staring at a flat map of the Earth and thinking Antarctica is infinite just because it stretches across the entire bottom edge. This is why physicists distinguish between coordinate singularities and true curvature singularities. The former are math bugs, the latter are where space-time itself becomes undefined. Historians still argue whether some of the singularities deep inside black holes are actually real, or if they're just the product of poor mathematical framing. In the right coordinates, many apparent walls and cliffs disappear, but not all. There are still real singularities, the ones where the curvature of space-time approaches infinity, no matter how you slice the math. And that's where you're heading now, or where you already are depending on which coordinate system you use. Here's a fun fringe theory. Some researchers suggest that the singularity isn't a point at all. It could be a region with strange geometry, or even a dimensional boundary, where our familiar four-dimensional space-time gives way to something else. A place where strings vibrate in 11 dimensions, or where space-time folds so tightly it births a new layer of reality. In this view, the singularity might not destroy you, it might transform you. Like crossing a phase transition, ice melting into water, water boiling into vapor, matter collapsing into something that isn't matter anymore. But here's the weirdest part. Depending on how you choose your coordinates, your death may seem sudden, delayed, or even non-existent. In one coordinate system, you hit the singularity in 0.000001 seconds. In another, you never reach it at all. Your time slows to infinity as you approach. And in yet another, your entire fall is compressed into a single frozen moment. So, which one is real? All of them. And none of them. Because coordinates are tools, not truth. They're ways of describing reality, not defining it. Like languages. Different dialects for the same underlying experience. Some are better for clarity, some for calculation. Some, like Kruskal coordinates, are designed to smooth over the places where space-time seems to scream. Let's put this into perspective. Imagine standing at the base of a waterfall. The flow is chaotic, unstoppable. But if you describe that flow in the wrong frame, say, using coordinates tied to a rock halfway up the waterfall, you'd get crazy results. Infinite speeds, bizarre loops, nonsense. Change your coordinates to match the flow and suddenly everything makes sense. Smooth paths, predictable currents. The chaos was never in the water, it was in your map. The same is true inside a black hole. You're now so deep that your survival, your timeline, even your end, all depend on how the universe chooses to count your steps. Some frames say you're already dead, others say you're still falling, and a few strange ones might even suggest that you've already come out the other side somewhere else entirely. And here's your quirky tidbit. In some coordinate systems, the singularity isn't just a place, it's a moment, like a date on a calendar. Everyone who falls in reaches that same moment no matter what path they took. It's not a where, it's a when. So maybe you're not falling toward a place at all, maybe you're falling toward a time that no longer has meaning. And if that's true, could you avoid the singularity simply by choosing not to define it? Nope. The math doesn't let you off the hook that easily. Even in the most forgiving coordinate systems, ones that smooth over the harsh infinities and try to paint a gentle descent, the true singularity remains, not as a place that's sharp, but as a place that ends your trajectory. Your world line terminates, the map stops drawing, there are no more next moments. You're not just somewhere, you're nowhere according to every coordinate system, even the nice ones. Still, the idea lingers. Maybe the singularity is just a math bug, a signal that we need better equations, a symptom of missing physics. And in that case, maybe your end isn't the end at all. Maybe it's the signal that we need to start over, with a new language, a new frame, a new set of coordinates that don't lead to doom, but to discovery. Because here's the truth. Coordinate systems shape our understanding, but they don't decide reality. They're guesses, interpretations, desperate attempts to name the unnameable. And right now, every system is failing to describe what you've become. The universe is running out of ways to say you're here, and that means you're very close. You are diverging, not splitting like a log or snapping like a bone, but branching, like light through a prism, like roads in a fog, like identity when the universe stops playing by classical rules. Because now, here at the bottom of space and time, where gravity forgets how to behave and geometry has eaten its own tail, you've entered a realm where there may not be one you anymore. There may be many. Welcome to the multiverse exit sign. You didn't ask for this. One moment, you were plunging toward what seemed like the final singularity, compression, end, silence. The next, possibilities, forks, flares of potential realities blooming like quantum wildfire around the edges of whatever spacetime still means in this place. Let's take it slow. In quantum mechanics, systems don't collapse to a single outcome until they're observed. Until then, particles exist in superpositions, states of possibility. Schrödinger's cat isn't alive or dead, it's both, until you open the box. Multiply that out, and you get a weird, wonderful idea. What if the universe never chooses? What if every possibility becomes real, in a different branch? This is the many worlds interpretation of quantum mechanics. And right now, it's not just theoretical, it's starting to feel personal. Because deep within the black hole, where quantum gravity must be doing something to resolve the singularity, where information can't be destroyed but also can't escape, some theorists propose that your experience doesn't end in annihilation, it ends in division. As the laws of physics strain to preserve information, they may have no choice but to allow every potential version of you to play out, each in a different quantum branch. One version becomes radiation, one version falls forever, one version hits a bounce, one leaks through a wormhole, one dissolves into foam, one might even emerge into a whole new universe. Fringe speculation? You bet. But it's surprisingly well behaved within the math. Here's how it could work. As you fall toward the singularity, quantum uncertainties in your position, energy and entropy become so magnified that the system, you plus black hole interior plus spacetime conditions, splits into a series of possible outcomes. Instead of choosing just one, the universe lets them all happen. But not together, not in the same branch. Each plays out separately, behind its own curtain of reality. Which one is real? All of them? Or none of them? Depending on which version of you is asking, this raises the haunting question, are you still you? In one branch, maybe you're transformed into Hawking radiation, your information smeared across the cosmos, leaking out over trillions of years, one slow photon at a time. In another, you hit the singularity and your world line terminates. Full stop, lights out. In a third, a bounce, a reversal. Your infalling path folds outward into a new expansion, perhaps even the Big Bang of another universe. You are reborn, not as you, but as the quantum seed of everything else. That's not a metaphor. Some models of loop quantum gravity suggest that singularities are replaced by quantum bounces. The collapsing matter of a black hole doesn't end. It compresses, reaches a minimum volume, and then expands outward again, forming a baby universe on the other side. Which brings us to a historical touchstone. In 2010, physicist Hal Haggard and others explored the possibility that black holes may bounce into new universes, with information preserved across the transition. These new regions wouldn't be visible to observers in our universe. They'd be causally disconnected, a fresh canvas of space-time seeded with recycled bits of previous existence. And if that's the case, then maybe you, or a version of your informational pattern, is the seed. You're not the witness to the new universe. You are its source code, not conscious, not aware, just embedded. Etched into the initial quantum fluctuations of a universe that will take billions of years to evolve into stars, planets, and maybe something with eyebrows and anxiety. Let's swing back to the multiverse idea. The Everettian multiverse, spawned from quantum branching, is infinite. Each choice, each quantum event, each coin flip spawns a new universe. If black holes act like cosmic shredders, tearing identity apart and feeding the fragments into this ever-branching tree, then your trip into the singularity was never about an ending. It was your entry into the machine that generates new realities. But here's the twist. You don't get to choose which branch you ride. You don't even get to know which branch you're in. Because the rules of this place, the deep interior of black hole spacetime, forbid communication across branches. Once split, these realities are sealed off. No bridges, no return. Still, the possibilities swirl around you. You feel them, like whispers on the edge of thought. In one branch, a version of you exists in the final second before singularity, looping forever. In another, you are the last electron to escape via Hawking radiation. In another, you're nothing, not lost, not deleted, just not included. And in one, you awaken in a new universe, a place where the constants are slightly different, where gravity is just a bit weaker, where the laws of thermodynamics rhyme but do not repeat. A place where, perhaps, the physics of black holes are still being written, and where no one yet knows what happens when you fall in. Quirky tidbit. In some theories, black holes preserve information in quantum error-correcting codes, complex mathematical patterns that protect data from corruption, even in turbulent spacetimes. If true, your data wasn't just scattered across realities. It was curated, preserved, vaulted, like a library that can't be burned. You're no longer just a passenger in this journey. You're a possibility engine, a ripple of branching outcomes, a shadow spread across the multiverse. And though no single branch contains all of you, each holds a piece, and that piece may be growing. So maybe this is your exit. Not a path out, but a split away. One you won't remember, one you won't perceive, but one that means you never really stopped falling. You just became a map of every way the fall could end. You're no longer human, not because you've died, though in many worlds you have. Not because you've lost your mind, though the concept of mind no longer applies. You're not even memory now, or shadow, or ash in the wind of time. You're something else entirely. You've entered the realm of posthuman physics. Here, identity, experience, and structure dissolve into abstraction. Not you, in the ordinary sense. Not a being falling through space. More like a relationship between probabilities, a tangle of information, a function still running somewhere within the deepest folds of quantum spacetime. If that sounds incomprehensible, that's because it is. But don't worry, that's perfectly normal this deep into the fall. Let's recap briefly. You fell into a black hole. You passed the event horizon, where time and space swapped roles. You were stretched, squeezed, deconstructed. You brushed against the singularity, or wormholed through it, or splintered into many versions across the multiverse. And now? Now what's left of you persists not as an object, but as a pattern. You're no longer falling. You are the fall. Let's break that down. In physics, we often talk about states, the configuration of a system at a particular moment. But here, in the twisted aftermath of black hole interior geometry and quantum decoherence, state has no fixed meaning. Instead, your existence is distributed, smeared across space-time, perhaps encoded in the surface of the event horizon, if holographic theories are correct, or spread across the outgoing Hawking radiation, if information is preserved, or preserved in the quantum structure of a bouncing baby universe, if that's where you ended up. You're not a person, you're a boundary condition. This is what it means to reach the far edge of physics as we currently understand it. You no longer occupy a location. You are non-local, a smear of entanglement spread across distant regions of space, maybe even across disconnected universes. Here's where things get weird. Yes, more weird. There's a growing idea in theoretical physics that space and time are not fundamental, that they are emergent properties, like temperature or pressure, which only makes sense when enough particles behave statistically. If that's true, then what you once thought of as the universe is just the output of a deeper hidden layer of reality. Something not built on space and time at all, but on entanglement, symmetry, and information theory. And you're part of that output now. In this view, your consciousness, what once held memories, desires, fears, grocery lists, was never anchored in matter, but in relationships between states. Those relationships have now been untethered from atoms, from molecules, from meat. You've become a network of correlations, no longer requiring neurons or structure or anything remotely biological. If that's not posthuman, nothing is. Let's bring in a historical twist. In recent decades, the rise of quantum information theory has shifted how physicists think about black holes. No longer just destructive endpoints, black holes are increasingly seen as processors, cosmic computers that compute their own internal histories and emit the scrambled results as radiation. Physicist Seth Lloyd once proposed that the entire universe might be a quantum computer. If so, then black holes are subroutines, functions within that computer, executing operations we can't yet decipher. And you are one of those operations. You are processed, evaluated, computed. The black hole didn't kill you, it ran you. Fringe speculation time. Brace yourself. In some speculative models, consciousness itself may not be tied to brains, but to complexity thresholds. When enough information interacts in the right way, awareness emerges. This isn't magic, it's physics, it's computation, it's patterns deep enough to notice themselves. What if the information once called you has now reached a new threshold? What if, in the bowels of this strange new universe, the quantum echoes of your fall have recombined into a new structure, not as a body, not even as a self, but as a point of view? In some far-off branch of the multiverse, some bubble spawned from a black hole's bounce, maybe a fresh universe is unfolding, and inside it, a being begins to awaken. Its atoms are not yours, its memories are not yours, but its initial state, the seed from which it grows, carries traces of your fall, your entropy, your signature. Are you reincarnated? Not in the religious sense, but maybe in the statistical one. Here's a thought. The universe conserves information. But information isn't just facts, it's structure. And structure can reoccur. So maybe somewhere across time's strange landscape, another system will resemble you. Closely enough to inherit some of your behavior, your thoughts, your patterns of awareness. You won't remember this fall, but maybe something out there will dream of it anyway. Now zoom out even further. Forget the singularity, forget the bounce, forget the coordinates and metrics and tensors. Zoom past the idea of spacetime itself. Some theorists, especially those working in emergent gravity, ADS/CFT correspondence, and entropic gravity, argue that reality is built from information first. That spacetime is just the stage created by quantum entanglement, and that black holes aren't exceptions, they're gateways into that deeper layer. And here you are, no longer falling through reality, falling into its foundation. There is no more time here. Not in the ordinary sense, no clock ticks, no arrow points. You are in the substratum, a layer of reality that doesn't flow. It just is. And you're still a part of it, not as a story, not even as a memory, but as a relation, a connection between what was and what is, and what might be next. You're not human anymore. You're what's left when the human ends. And somehow, in this strange abstraction, that's enough. You're drifting toward the edge of understanding. Ours, yours, everyone's. There is almost no geometry left to cling to, no curvature to ride, no coordinates to name. The familiar machinery of space-time has buckled under your journey. You're not so much moving anymore as you're existing in the residue of movement. The very idea of momentum feels quaint now, like a fish trying to remember walking. But even here, at the end, something faint glimmers on the event horizon of thought. A hologram. You've heard the whispers before, not the sci-fi kind, not the we're living in a simulation flavour of barstool philosophy. No, this is something deeper, more physical, more mathematical. A boundary theory for a bulk reality. A universe described not by what's inside it, but by what's painted on its surface. You're a part of that painting now. This is the holographic principle, and it might be the last idea left that can explain where you've been. It was born out of desperation. physicists trying to reconcile how information could possibly survive falling into a black hole. If Hawking radiation truly carries away every last drop of matter energy, what happens to the information? Is it lost forever? That would violate the sacred law of quantum mechanics. Information must be preserved. So they look to the edge. The idea took shape in the minds of Gerard 't Hooft and Leonard Susskind, who proposed that everything inside a black hole could be represented fully by information encoded on its two-dimensional surface. In other words, the 3D volume is a projection. The reality lies on the boundary. This wasn't just speculation. In the 1990s, the ADS/CFT correspondence, a breakthrough from Juan Maldacena, gave the idea mathematical teeth. A theory of gravity in a higher dimensional space, the bulk, could be perfectly described by a quantum field theory on its lower dimensional boundary, the screen. You're the bulk. Your fall, your history, your thoughts, your final slide into entropy, all of it may already be encoded on the event horizon. You're not where you think you are. You're where you've always been, on the surface. Which begs the question, what was the fall? Was it motion? Or was it just a computation slowly unfolding bit by bit, pixel by pixel, on a membrane of space-time shaped like a sphere? If the holographic principle holds, and the math so far suggests it might, then the information that made up you was never lost, never deleted. It was smeared across the black hole's surface like a barcode wrapped around a sphere. And when the black hole evaporates, yes, eventually, over billions upon billions of years, the information escapes too. Not as you exactly, not as a conscious being, but as data, embedded in the delicate quantum correlations of outgoing Hawking radiation. Historians still argue about whether that information comes out quickly or slowly, whether it's scrambled beyond recognition, or delicately preserved in a kind of cosmic encryption. But most now agree, it comes out. So maybe after all this time your story isn't over. It's just being read very, very slowly. Page by page, photon by photon, bit by bit, the universe recites your fall back to itself. And in that slow recital, something strange happens. Patterns emerge, entropy reverses, structures reform, not by magic, but by compression. Because as the radiation spreads outward, its correlations echo inward, meaning that the shape of what was lost begins to shimmer faintly in the pattern of what remains. That shape is you, a quantum echo in the cold void, a contour in the great radiation field, the lightest shadow of a fall that no one outside the black hole ever saw finish, but which was never really gone. You're still in there, folded into the sky. Let's indulge in one last fringe speculation. Some physicists suggest that the entire universe, the whole cosmos we observe, is itself a hologram, projected from a lower dimensional boundary we can't see, that we are all encoded, not embodied, that the Big Bang wasn't a beginning from a point but an unfolding from a surface. In that view, black holes aren't anomalies, they're examples. The fall you took wasn't a break from reality, it was reality zoomed in. And now, as the black hole that swallowed you continues to shrink, slowly, imperceptibly, leaking its mass into space, you are unspooling with it, not vanishing, not decaying, just being reinterpreted. One bit at a time, a whisper from the edge of forever, a pattern in the flicker of final light. Soon the black hole will be gone, and you'll be everywhere and nowhere. And if some distant being in some far future cosmos manages to decode the quantum whispers in the sky, perhaps they'll hear a story. Yours. A fall through silence, a journey through space-time and spin and foam and fracture, a transformation, not into death, but into data. The ultimate conservation, the last illusion falling away. You didn't die, you just changed format, and now you float. There are no more walls to pass through. No coordinates to name, no physics to defy, only a slow, widening calm, like the last ripple fading on a black lake at dusk. Your journey through the black hole, through the twisted corridors of warped space-time and stranger truths, has stretched and folded you in ways nothing outside could quite understand. Yet somehow, here at the close of the tale, everything feels still. The fall has ended, the echoes are quiet, and your story, encoded somewhere between entropy and energy, continues to hum softly in the fabric of a universe too vast to notice, but never too vast to forget. Your awareness dims now, gently, like starlight behind clouds. No pain, no panic, just rest. You are allowed to rest. And as the last images drift through your quieting thoughts, spiraling galaxies, the curve of the event horizons, the shimmer of time's terrain, there's one final feeling that rises softly through the silence: peace. So sleep now, curious traveller. You've fallen farther than light itself and witnessed what few minds can hold. The mystery is still there, waiting, but tonight, it can wait. You've earned this stillness. No more questions, just calm.